So I'm very excited to welcome our first speaker of the evening, Assistant Professor Victor Muñoz Sanz. Victor is an Assistant Professor of Urban Design at the TU Delft. His research focuses on the implications of technology for architecture and urbanization. Victor holds a degree in architecture and a PhD from ETSA Madrid and a Master of Architecture in Urban Design from Harvard University. His research on automated landscapes was exhibited at the Venice Biennale in 2018.
Well, thank you for the organizers of INDESEM for the invitation. And I'm very happy to share my research for this event. Dutch solutions for agriculture are considered to be the new super Dutch. Automation, big data, robots, artificial intelligence are presented as solutions leading to the future of food production, and they're diffused in so many ways with fascination and wonder. However, in the recent times, the prospect of such a rosy future has been at odds with the political reality of the country, in the Netherlands, with concerns about labor conditions and the environmental footprint of indoor horticulture, or farmers protesting on highways and in The Hague as regulations against nitrogen would mean, for example, to basically halve the population of cows in the country. In this presentation, I will try to unpack this situation and highlight how human and non-human life entangles with buildings and landscapes at the intersection of digital platform technologies and big data. I will present cases in dairy farming and horticulture as microcosms embodying broader social and ecological opportunities, dilemmas and contradictions related to the digital transition, and question what they might mean to architecture and the special disciplines at large. This is part of my research on automated landscapes conducted at Het Nieuwe Instituut in Rotterdam and also at TU Delft, and follows my fascination with understanding the socio-spatial implication of the use of automation and big data in productive environments. The contemporary dairy business looks quite different to those days in which milkmaids did the work in small family farms, as robots, big data, and AI have entered the barns. Now, by means of conditioning techniques, cows go to robots to be milked. The circulation of cows in space is relatively free, and so the design of the building has changed to accommodate free flows of cows as they rest, eat, and are milked. The space is shared by animals and a collection of machines that do the work in the barn. They clean it, they prepare the feed for the cows, they bring the feed to the barn, they brush the cows, and science and automated smart light systems allow for extending the daily productive cycles. For example, light of a certain wavelength stimulates hormonal balance and activity of young and lactating cows who can be awake longer, while dry cows need to rest more. All these diverse elements are connected. Machines have sensors, and the cow itself has a collar which is full with sensors that collect data on the animals and its interactions with the different parts of the system, its activities, and its health. Data goes then into a dashboard software in which the farmer can observe the performance of the herd and of each individual cow. Such big data technologies are being explored for concepts such as individualized milk production, so customers with specific dietary or health requirements could choose milk from a particular cow based on the amount of fat, lactose, protein, etc. The amount of data is huge, so farmers sometimes have difficulties to make sense of it in a systemic manner and take decisions based on raw information. So the market has developed an AI assistant, which is called IDA, which analyzes the data and through pattern recognition informs the farmer of problems that might be in need of action and suggests solutions in an easy manner. The amount of data per cow is so big that farmers and service providers need extra cloud storage, and that big data also is used to feed and train AI systems. So a new market has emerged, which is that of the collection, storage, and sharing of big data across farms and companies. It's not only farmers or robot manufacturers that contribute to data to these data banks, but also companies helping farmers to improve their herds through artificial reproductive technologies. So then, data on the genetic origin of cows is cross-linked with data on their performance in their barns, on the productivity, on the milk characteristics, and on their behavior. Interestingly, one of the traits included in these listings of reproductive cells of highly productive cows and bulls is the suitability of the animals for robotic milking. That indicator is based on the behavior of the animal in the relation with the robot, so how docile it is, but also by characteristics of the bodies, such as how broad the cow is and the position of its udders. Technology allows farmers to have more precise control of larger herds, increasing the scale of production with a smaller manpower. Those who put forward these technologies or embrace them in their business name animal welfare as the main gain of automated systems. The cows gain freedoms, freedom from stressful contact with humans and freedom to behave naturally. Of course, one can question what behaving naturally means, as these animals are the result of reproductive selection and breeding based on traits indicating how they will perform in a robotic farm. But going back to the reported benefits of the system, one of the main ones is that it gives freedoms to the cows to be milked whenever they want. So they're free to go out and graze in the outdoors and return to the barn when needed. The cow is happier and healthier, the story says. The problem is when too many cows go outside. And this fantasy of achieving a perfect closed, self-regulated system encounters difficulties, as its externalities clash with ecological balance. Cow manure contributes to almost half of the emissions of nitrogen and phosphates in the country. These chemicals have dramatic effects on the landscape, as soils become richer in nutrients and other species replace existing ecosystems. That is the reason why the Dutch government, following European directives, has suggested a change of model in agriculture and farming. Human ingenuity has managed to develop a techno-fix for this problem. So now barns will have sewers with separate collection of manure and urine, and machines will transform those in fertilizers that can be then sold for other purposes elsewhere. That, of course, means that the cows cannot go outdoors anymore. So what about this organic and grass-fed cow milk? The solution is another robot, an automated vehicle that cuts and harvests fresh grass from the fields, and then brings it indoors to the cows so they can feed on it. So of course, one wonders, what is the meaning of such a future of automated monocultures of grass and of indoor environments for cows, for a cultural landscape, for biodiversity, and for the animals themselves? A different type of data-driven monoculture is happening indoors as well, in the Dutch horticulture industry. In these automated greenhouses, flowers and ornamental plants grow in pots placed on automated rolling platforms that form continuous horizontal surfaces floating above the actual ground. Walking aisles are unnecessary, optimizing and maximizing production space. Ventilation, lighting, fertilization, and irrigation are perfectly controlled by automated systems, and space is used more efficiently. Sensors collect all sort of data, which is then presented to managers in dashboards. These are intended to help companies improve their processes and productivity, their use of resources, and also to forecast their harvest and plan better next seasons. Big data and digital platforms allow growers to manage more and bigger operations remotely. In fact, Our research suggests a link between scale and the embracement of automation technologies. Data show how there's a correlation between the growth of productivity, the growth of the average production site size, and a decline in the number of companies. Situations like company owners buying neighboring businesses and parcels to gain more space to enlarge the buildings are common in an area like Westland. As a matter of fact, between 2000 and today, the surface of the average Dutch greenhouse is now 2.5 times bigger, and the number of horticultural companies has been reduced by 2/3. Despite all these, elements of uncertainty remain. The presence of human operators sorting pods and picking vegetables show that by now it is only by humans that can handle unexpected incidents or manipulate delicate products. The difference is now that the farmer, now also a manager, can easily monitor the labor through a digital platform. In the greenhouse, a combination of radio frequency tags and different machines allow to measure employees' productivity and work quality. Labor performance software help managers set goals and trace back any wrongdoing, so they can know who's responsible for any mistake done in the whole chain of production. Productive employees will get bonuses, but the lower ranking ones most likely will not be rehired in future harvesting seasons. This is very similar to what Amazon uses in their fulfillment centers, for example. And in a way, it's very similar to the idea of the cows. So for example, when the dairy farming smartphone app sends notifications to the farmer when an animal is possibly ill, automated fences direct them to special zones for cows that need attention and prevent the disruption of the traffic of the most productive animals, therefore preventing that the whole system gets clogged by unproductive animals. The majority of these workers in the glass greenhouses are flex migrant workers. Their relation with the employees is also mediated by digital platforms. These apps show them job opportunities across companies and all sorts of contingent jobs in horticultural logistics. In total, around 2,000 migrant flex workers, mostly from Poland or Ukraine, are expected to be needed in the coming years. These temporary workers are housed in rental homes shared by many, or in the so-called hotels, dormitory buildings that are built right at the productive clusters, surrounded by infrastructure and lacking any form of social amenities or the possibility of integration with a community. It is just about solving the housing question in the most efficient manner possible. While these workers are essential for the economy and of the Westland, the way the housing question is being solved with enclaves generate not in my backyard attitudes. People think it's wonderful that these workers get a place to live, but not here and this way. Such situations, which we could generalize to other sectors, such as logistics or meatpacking, put forward a new interaction, a new version of the unresolved housing question, now in the context of the digital age, marked by the temporary and cross-border mobility. To conclude, I hope that after this short lecture, you will join me in looking with critical eyes at the seductive and fascinating images of automated landscapes, and that you see how, in many cases, automation, as a solution embodying ideas of sustainability and efficiency, is used as a cover-up of a modernization project based on economies of scale that is far from actual social and environmental sustainability. And also to consider how these courses on technology, big data, automation, and the like tend to shadow that humans and other beings are still and will be part of the productive system for a while. These discourses also shadow the infrastructures that support the pools of big data that support these systems, but that will require another lecture. Beyond the countryside, it's us, As cows with a collar, we are giving away mountains of data, somewhere in servers. Our internet activity for our phones is linked to our health of traffic or behavior data, opening new possibilities. Of course, some of them are good for personalized experiences, to perform better at sports or work, to design better cities and buildings, maybe with an AI assistant to make sense of the tons of data available, but also with serious implications for policing, social control, manipulation, access to services, and precarious labor. The question of repositioning architecture and the special disciplines at large in the digital is then highly relevant, as it is to open a discussion not so much on what technology, big data, and AI can do for us, but about their broader meaning across the scales and bodies of both of humans and non-humans, and the new type of parallel agendas and questions that architects and urbanists could engage with in order to make the technological transition truly sustainable, environmentally and socially. Thank you very much.